Okay, we're going to look at our last type of compound. Alright, so today what we're going to do is we are going to look at acids. So, how can we identify if we are looking at an acid? Well, usually starts with a hydrogen. There's only one instance that we will not see it start with a hydrogen. Okay? So if we're looking at chemical formula, hydrogen's first element, it's going to be an acid. Okay? Now, how do we name acids? Well, we have to look at what kind of anion is with the hydrogen. Because actually, when we put acids into water, they break apart into ions. We always get a hydrogen ion. And some type of anion. So when we're trying to figure out the name of it, anion comes into play. And particularly the ending of the anion. If our anion ends with ATE, this is how we name the acid. We drop the ATE off the name of the anion. We're going to add IC in its place. Then, of course, we have to write the word acid. And what we'll do is we'll get the rules first, then we'll kind of work on some examples so we kind of see how this works out. Okay? If our anion ends with ITE, we're going to drop the ITE ending. We're going to add OUS in its place. And of course, we're going to write the word acid. And what's the third ending that our anion can possibly have? I. Yeah. So if our anion ends with IDE, we drop IDE. And with this one, we're going to add in a prefix with it as well. We're going to add the prefix hydro to the name and the ending of IC. Then, of course, we write the word acid. Okay, so for this, definitely get out your periodic table, get out your polyatomic ions. If you haven't attached that to your periodic table yet, some of you, I will get you, there's a handout that I gave you, passed out on Monday, so you'll get that here in a little bit.
Cool, we gotta know all these for the test. What? On Friday. They'll do animal charges.
Why? You should get messages.
So, the test on Friday is over knowing every single one of these, right?
Okay, so, trying to figure out the name of the acid. Here's our first example. Oh. So, trying to figure out the name of the acid. Well, like I said, acids usually start with hydrogen. So to figure out the anion, what we're going to do is we're going to cover up the hydrogen. After the hydrogen is our anion, right? So we have ClO3. Well, since it's more than one element, that's telling you that it's going to be a polyatomic ion. So if we look on our polyatomic ion list, which one has the formula of ClO3?
Chlorine.
Chlorate. So it ends with ATE. So to name this as an acid, we drop the ATE and we add IC. So this would be
Chloric acid.
chloric acid. Okay, any questions for that first? No? Okay, let's keep on going. HBr. Alright, so once again, cover up the hydrogen. What is our anion? Well, the element is bromine, but the anion would be bromide. Because remember, element by itself as an anion ends with IDE. So, we have an I, this one. We drop the IDE. We add hydro as prefix and ic as the ending. So this would be hydro bromic acid. Questions? Any kind of questions there?
How acidic are both of those?
What?
How acidic are both of those?
Let's see. Hydrobromic. It honestly kind of depends on the concentration. Now, one of the things I can tell you, this is a weak acid, which means it really doesn't like to break apart a whole lot. This is a strong acid. It likes to break apart 100% of the time that you put it into water. Okay, you take second year chemistry, we'll get more into that information. But yeah, if we don't know the concentration, I really can't tell you how acidic they are. Hydrobromic HBr, that's not a fun one to play with. Chloric acid, I've never been around chloric acid before, so I can't tell you a whole lot. Okay, any other questions right now? Nope. All right, so our next one, HNO2. Cover up the hydrogen. What is our anion?
Nitrite.
What is it?
Nitrite.
Nitrite. Okay, so it ends with ITE. How should we name this acid? Right. Nitrous acid. So you kind of see how this works out a little bit, ladies and gentlemen? Any kind of questions so far? Nope. Let's do at least two more together, then I'll give you a couple to try on your own, all right? H2SO4. What is the anion that we need that we're working with in this one?
Sulfate.
Sulfate. Okay, now, I want you to put a star in your notes somewhere about this one. Okay, so when we have an acid that has sulfur in it, particularly kind of in the name of the anion, sulfate has sulfur in the name of it. When we name it as an acid, we're actually going to use the word sulfur in the naming. So we still drop the ATE and we had IC. This would be sulfuric acid. Okay, so why are we using sulfur's full name in this situation? Well, which one sounds better? Sulfuric acid or sulfic acid? Well, hopefully you kind of think sulfuric sounds a little bit better than sulfic. There's another element that we have to kind of watch out for in this situation. Phosphorus. All right, so if we have phosphate or if we have phosphide, we use the name phosphorus in the naming of the acid. Let's kind of look at that example. Okay, H3P. So our anion is
Phosphorus.
phosphide, not phosphate, but phosphide. So we're going to use, we still have to add the prefix and the suffix to our name of our acid. So this would be hydrophosphoric acid. Any questions? Kind of see how this works out a little bit? Okay, I'm going to give you a couple of acids. Try to figure out what their names are going to be. All right? Now this last one, you know, I just said that usually starts with an H for the acid. Here's that exception to the rule. This one, the H is at the end of the form. Okay?
So would it just be the same thing?
Yeah, we still, you still cover up the H and see what the
Okay.
anion's going to be, but in this one, when we write out the formula, we have to put the H at the end. Yeah. You look at the name.
Oh, okay.
Bless you.
Thank you. Our test is about knowing these and the names and the charges, right?
Correct. Yeah, I'd say 20 of them, so 10 of them. Yeah, I'll have the formula with the charge, write down the name of it, and the other 10 vice versa. I do anything, you have to write down the formula with the correct charge.
Okay.
Yeah, when's that, Bernie?
Yeah.
Are you ready? Okay, our first one, HClO2. What do we come up with for the name?
Chlorous acid.
Chlorous acid. How many of you came up with chlorous acid for this one? That is correct. What about our second one? H2CrO4. What we come up with for that one? No.
Chromic.
Yeah. Chromic acid. How many people came up with chromic acid? That would be right. H2SO3. What did we come up with for that one?
Sulfurous acid.
Sulfurous acid. Come up with sulfurous acid. Okay. Then our last one. What we come up?
Acetic acid.
Acetic acid.
Yeah.
Acetic, yeah.
Acetic acid. How many people came up with acetic acid? Okay. Wonderful. Now, kind of give you some information. Acetic acid. A lot of you probably have this at home. Maybe. The common name for acetic acid is vinegar. Yeah. Okay. So, any kind of questions about when given the formula of an acid, trying to figure out its name? We need to do any more examples, or we're kind of good to go on this aspect? Okay.
Start a new page today.
Well, let's flip it. Well, let's get the name and try to figure out the formula. Okay, so our first example, hydrochloric acid. The way to figure out the formula of an acid, kind of the same way that we figure out the formula of an ionic compound. But our cation always is going to be the same thing. It's always going to be hydrogen ion. Now we just need to figure out what is our anion. So if we look at the name, for this one we have hydro and ic as part of the name. So that's telling us that our anion ends with IDE. So we're looking at chloride. Well, if you look at your polyatomic ion attachment, do you see chloride anywhere on the polyatomic ion attachment?
No.
No. So that's telling us that it's going to be
Yeah.
chlorine as an ion. So what kind of chart does chlorine have as an ion? What group is it in? Group number 7. Group elements in group 7 have a
-1.
-1 charge. Okay, so now that we have our two ions, hydrogen with a +1, chlorine with a -1. Are our charges like numbers?
Yeah.
Yeah, so we're 1-to-1 ratio. Our formula is going to be
HCl.
HCl. Okay, now, have you ever been around hydrochloric acid before? Yeah. You carry it with you every day. Where at? stomach acid is hydrochloric acid. Okay? Now, other thing, stomach acid, if you get this actual hydrochloric acid on your hands or on your, it hurts like crazy. Okay? Let's try another one. Okay, bromic acid. What's our cation?
H.
Yep. Hydrogen ion. Okay, now, anion. Well, since our acid just ends with IC, this is telling us that our anion ends with
ATE.
ATE, so we're looking for bromate. Well, if it ends with ATE or ITE, it's definitely a polyatomic ion. So what is the formula for bromate?
BR3.
BrO3 with a -1 charge.
Okay, BrO3 with -1 charge. So looking at our cation and anion, what should be the formula for bromic acid?
HBrO3.
HBrO3. Questions? Any kind of questions? No questions? Okay. Let's see. Okay. Hydronitric acid. What'd you see how far you can take this one? Anybody like to say what they came up with? Good?
H3N.
Okay. Anybody else come up with H3N for this one? That is correct. So you might need to see how we come up with H3N. Okay, so cation is always going to be hydrogen ion, right? So hydronic is telling us that our anion ends with IDE. Okay, so if you look at your polyatomic ion and try to look for nitride, if you can't find it, that should be telling you, okay, this is the element by itself as an ion. So nitrogen as an ion. Well, nitrogen is in group number 5, so it'll have a -3 charge. So that everything cancels out, we need to have 3 hydrogen ions to cancel out the 1 nitride ion. So our formula, H3N. Okay? Try one more. We kind of see how this works out. One more? All right. Let's see. What I want to do. oxalic acid. What are we coming up with for our formula? Irene?
H2C2O4.
H2C2O4. Anybody else come up with H2C2O4? That is correct. You might need to see how that comes out to be. Okay, so, always hydrogen ion, right? So, our acid ends with IC. That's telling us that the anion ends with ATE. So, ATE, IT, look at your polyatomic ion list first. So we're looking for oxalate. Oxalate's formula is C2O4 with a -2 charge. So looking +1, -2, the least common multiple is 2. We need to have 2 hydrogen ions to cancel out the -2 charge from the oxalate. So that's why our formula is going to be H2C2O4. Okay? Any other questions? So we kind of see how this does kind of, when we're trying to figure out the formula, it's kind of like figuring out the formula of an ionic compound. But the cation is always going to be the same thing. It's always going to be that hydrogen ion. All right? So no questions? All right, so on Canvas is the assignment over figuring out names of acids and determine their formulas. Work on it the rest of the time. When you get done with it, show it to me so I get the points in the grade book. Hopefully we can go over it before we leave today.